In this video, we are going to talk about electronegativity and bond polarity. What is electronegativity? It is the ability of an atom to attract electrons towards itself. For example, if we look at electronegativity of hydrogen is 2.1 and nitrogen, let's say nitrogen is 3.0. Nitrogen has higher electronegativity, which means if we put the electrons between hydrogen and nitrogen, these electrons will be more towards nitrogen because it has the more ability to attract electrons. In the periodic table, now these electronegativity values will be given to you in the exam. And if you look in the electronegativity chart, you will see that the electronegativity values increases across a row of the periodic table and it decreases down a column. If it is decreasing down a column, means we put it like that, means it is increasing up in a column. So electronegativity increases from left to right in a period and decreases down the column. So let's say if I write down the, let's say, second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, which one is going to have the highest electronegativity out of these elements? Fluorine. Similarly, if I am writing the first A column, first A group, lithium, sodium, potassium, rubidium and so on, then out of these elements, which one is going to have the highest electronegativity? Lithium, because it decreases when you go down the group. We're going to use this concept of electronegativity to explain the concept, another one, polar or non-polar bonds. When you draw a bond between two atoms, that bond can be polar or non-polar. And what does that mean? When two atoms have the same electronegativity value or the difference is less than 0.5 units, the electrons are equally shared and we call the bond as non-polar. For example, let's take the example of H2. This is structure of H2. Now hydrogen, if you have both the atoms same, then the electronegativity difference is 0. Electronegativity of hydrogen is 2.1, 2.1. What's the difference? 0. So what type of bond is that? Non-polar. And what does that mean? That the electrons here, the two electrons in this bond, are shared equally by both these hydrogen atoms. Now let's talk about this. Here carbon and hydrogen. Hydrogen electronegativity is 2.1, carbon is 2.5, difference is 0.4. And again it says if the difference is less than 0.5, you can ignore that. So that means we are still going to call this bond as non-polar. That means electrons are shared equally by carbon and hydrogen. On the other hand, let's take the example of, let's say, carbon and fluorine. Carbon electronegativity is 2.5, fluorine is 4.0. Now what's the difference? The difference is 1.5. Now when two atoms have electronegativity or difference of 0.5 to 1.9 units, that means electrons are not shared equally and the bond is polar. So the bond between carbon and fluorine is a polar bond. These electrons are not shared equally. Instead, these electrons are more towards fluorine, and we show it like this. That shows that these electrons are more towards fluorine and the bond is polar. Now, a polar molecule, there is a difference between saying a polar bond and a polar molecule. A polar molecule, when we are calling the whole molecule as polar, it has either one polar bond or two or more bond dipoles that do not cancel each other. Now what does that mean? For example, let's take the case of CF4. Now carbon attached with 4 fluorine here, and let me get rid of draw this here. Now carbon fluorine bond is a polar bond. Why? Because the electronegativity difference is 1.5. So that means these electrons are more towards fluorine. But what's happening here, that even though we have 4 polar bonds present, still overall the molecule is nonpolar. Why is that? Because we have 4 dipoles equal in magnitude and in opposite in direction, so they cancel. So opposite in direction, so they cancel out each other's effect, so that makes the molecule as nonpolar. Now when we call a molecule as nonpolar molecule, that means either all the bonds are nonpolar or 2 or more bonds, dipoles that cancel. So for example, this one, even though it has polar bonds, the molecule is nonpolar. Let me take one more example. For example, here, let's take the example of CH3Cl, CH3Cl, or let's take CH3F, and that's Lewis structure of CH3F. Now this bond is nonpolar because electronegativity difference of carbon and hydrogen is less than 0.5. This is nonpolar. This is nonpolar bond. But this is a polar bond because fluorine is much more electronegative than carbon. So the presence of one polar bond makes the molecule polar. But if I have like this CH2F2 carbon, and I'm drawing this, so this is nonpolar bond, this is polar bond, this is polar bond, but they are equal in opposite direction, so their dipoles, the dipoles get cancelled, so overall the molecule is nonpolar. So what does it mean? How can we summarize it? That even if the molecule has a polar bond, that does not mean that the molecule will be polar. Molecule will be polar only if it has one polar bond or 2 or more polar bonds that do not cancel each other.
Made with Doodlecast Pro.